Hello, everyone. We're going to be covering chapter 7 of the concrete book that we teach in this class. This class is about the ingredients of the concrete and how we make the concrete work better, and we learn about concrete construction a little bit more. Everybody knows Portland cement is the glue that puts the concrete together. This cementitious materials that was made in England basically combine different materials to create that glue. The cement is made of it's a complex material, but it's made of all earthy material that are mixed together and grinded together. Cement is very hard on your skin. So if you want to see somebody who has worked on the concrete, just shake hands with them. From their hands, you will know that they work with the concrete. Unfortunately, as I said, concrete doesn't do very good with the skin. It's very abrasive. Some people have even allergies to it. But you can wear gloves and work around it with the trousers, and so you don't want concrete to get to your eyes. So whoever works with the concrete has to have the right equipment and be dressed right, because it's pretty strong chemical and it impacts your skin. A component or mix of the cement has lime in it, which you all know is very potent chemical. Silica, which is a little bit more neutral, basically sands and quartz. Alumina, which is mostly clay, shales, and slags, and iron oxide, which is the metal part of the Portland cement or cement. When you get the earthy materials and you combine them and you heat them together from lime, silica, alumina, and iron oxide, the reaction that these elements they have on each other will produce that white powder or the gray powder that's used for to make the Portland cement. Now, different parts of the world, some places you may have sand, some places you may have quartz. These are substitution from each other. Some parts, in some islands, you may have limestone, but you may not have chalk. You have to import the chalk or use your limestone that you have. So in order to make concrete, depends on where you are, you may have different ingredients to put together to make the soup. But all these, in different parts of the world, combination of them, can produce some kind of a concrete at different strengths. So when we say lime, lime could be various kind of materials. Obviously, you don't put marble into concrete, but you may have to. If you're in areas, all you got is marble type aggregates or crushed, you may have to use that. But generally, limestone is very prevalent all over the world. A lot of places in the world have that. Sand, most of you can find it. Clay is available in different parts of countries of the world. And then when you come to the iron ore or mill scale, we talked a little bit about this. This is what you get from the millwork, steel manufacturing, and blast furnaces. Where you get to find the limestone or some of these clay materials and stuff, these are the actually large quarries or mines that in a regular, normal day, you may not see these. But there are parts of the world, like near us, there's a large part of Mexico has got quarries like this. There are parts of the US that you can find quarries that it's all limestone. Well, you need to take the limestone or all this earthy material, as we spoke about, refine those and make them as pure, as clean as possible. And then that becomes one of the ingredients for the Portland cement. Same thing with the clay, same thing with the sand. There are places, mines or quarries that you can get that. So here's a quick process of what happens from the drilling or blasting a limestone or aggregates you need, large pieces of limestone rocks. They get shipped by the truck into some kind of a crushing equipment. After these rocks, they hit each other. They use the gravity to make sure crushing these rocks is not too expensive. Then you start taking them up to some kind of a incline to make sure the smaller, lighter material, they go up the incline, and then more heavy stuff falls back into the crushing mill. Well, smaller stuff go up there, get again further refined, further crushed, and eventually, again, through some kind of a sieve. I'll show you some pictures. This is diagrammatic, but you see, material again, through gravity, industry always try to make this process cheap as possible. So where you need the incline, they have to put the incline, they have to spend the money. But where you can use the gravity to dump the rocks, to crush them, they do that. After all, the pottery material, the raw material gets stored in some kind of a bin to be sent to the mill. Here you see the process of different kind of minerals stacked. Like this example was on top was where the limestone came and got stored. But you need to store all the 5 different ingredients or 4 different ingredients that we spoke about, because then they get mixed together. So at the manufacturing, concrete manufacturing, or Portland cement manufacturing, I should say, cement manufacturing, the cement, the mix of these elements, they come in, they either go to the further grinding, they go to dust collectors and make sure that you're not contaminating the earth. Then they go over some kind of furnace, and then they're pumped into containers that are now contain mixed material. That's one way. After this, then they're sent to the kiln for the mixed material to be heated all together. The same process that we spoke about, raw materials are grounded, powdered, and blended. We can have raw materials are grounded, mixed with water, the wet process. The wet process also exists. Some manufacturer uses wet process because that way they can achieve the mix better. So mix is going to have some water in it, but it's a different mix. Either way, dry or wet, they have to go to kiln because they have to cook the soup, or the material has to be cooked together. So the material, either wet or dry, goes through this kiln, this hot tunnels, which again, as it's traveling, it gets exposed to that heavy heat, and it becomes like it clinks. They stuck together, but they're very powdery, but clunking together. That material is also, again, grinded, refined, and conveyed. These clunks, as they go through several different processes, they become, again, back to a powder. Now you got 3 containers that now has got a concrete. And these containers are pumping different ways, different cement trucks. There's a bulk truck, there's a bulk car truck, that some of these are on rails. They fill the rails, and the rail bring the cement. Sometimes they put the cement on trucks. Different ways to carry that cement to the concrete plant to get mixed with rock and everything else. But this process of getting the material from quarry or mine, break them down, first starts with a big explosion at the hillsides, then the big rocky material are basically grinded, broken apart, very refined. The refined material gets mixed, cooked. Sometimes they expose them into the water. A clunks can generate. They further grind the clunks, and then they load them on a truck. This is the glue. This is dry glue. This is dry Portland cement. From here on, it goes to every city, or it gets into the bags and go to Home Depot. And people buy them from there. Sometimes by the rail, sometimes by the truck, sometimes by the unit. Here are good examples of the clunks, by the way, or clinkers, I should call them. These clinkers, they go through a very heavy grinding machines. And this is the heated tunnel that I was showing you that the material travels through. To make sure, because of that heat, these chemicals, they produce that glue for you. Now, when the clinkers are done, when they take them to the lab and test them, the clinkers show a lot of chemical reactions, chemistry that together makes the type 2 cement. So now here's the first indication that there are different cement types. They are all glue, but some are crazier glue than the other ones. Some are a little bit for different conditions. This type 2 cement is a normal cement, what we refer to as generally normal cement. This is typically a report that would be prepared by the cement plant chemist to show result of the concrete test. In other words, at the plant, when the concrete is produced, and let's say that, or the cement is produced, the cement needs to go out with some kind of a ticket out, indicating that is the material that is put on the bag and you buy it at Home Depot, or is sent to the some kind of a concrete batch plant in Irvine or in any part of the world to use. There are parts of the world that they don't have the refineries or the factories or the mine. What they do, they actually buy the bags. They buy the Portland cement. Very much like you go buy the Portland cement at Home Depot and you bring it home and mix it and you make your driveway or you make your sidewalk. There are countries of the world or parts of the world or even parts of the country that they don't have access to all this material. So they buy the glue bags. They buy the Portland cement. But that bag that they're buying comes with a ticket like this, that this is the ingredients, this is what you're paying for. These are the type of Portland cement, type 1, type 2, type 3, type 4, and 5. So there are 5 kinds of glue that is available in the industry for different purposes. Some of these glues make the concrete cure faster. Some of these glues make the concrete cures later on. Some of these glues make the concrete very prone to sulfates. I touched upon that the concrete needs to be sulfate proof or fast curing or late curing. But the element that makes them fast curing, late curing, or sulfate resistant is the glue, is the Portland cement. Am I clear? In industry, we say use type 5 concrete, but that does not mean you got to change the sand, the rock, none of that. You change the glue. That's the importance of the glue. That's the importance of cement and 5 types of cements. This is the chemistry behind 5 types of cement. You don't have to know all these. All you need to know to produce a different concrete type, you need to add to it different kind of cement. You get 5 different kind of concrete because you have 5 kind of glue, 5 kind of Portland cement. Now let's see what's the difference between these types. Type 1 common, regular cement for general purpose, when the special properties of other types are not required. Type 1, construction. Type 2 is a little bit modified cement, generate less heat at a slower rate than type 1. So a little bit slower, a little bit less heat, more workable. That's why we emphasize type 2 a lot in most of the jobs. However, high early strength cement, if you know rain is coming, if you know the cold weather is coming, if you know you need to hurry up, if you have only limited number of crews, but only one day, let's say you can bring 30 people to finish your concrete, but only one day you got these people. That's the concrete you want to use. Low heat generates less heat than type 2. This is for Vegas. This is for hot climate. This is for Inland Empire, San Bernardino, wherever you're working, which is, you name it, Middle East, wherever, it's very hot. You want to use type 4. And last and final, sulfate resistant. This is Irvine, where you have high sulfate, and city of Irvine, no matter what you do, they want type 5 concrete. Anything you do, you know. So make sure tonight, if you understand these 5 types of cement, I've accomplished my big task, because that's a part of the delivery for tonight. We may not repeat this again. So make a neat note. I'm going to take a few minutes. Try to just run it by your mind. What are the differences? And it's written right here on the screen.
Question: which one's for water? Exposed to water, like Bay Bridge.
Again, depends on the climate. What are you exposed to, weather or water? If you, let's say you're exposing to ocean, rivers, salty water, you probably want to go type 5. If that's what you mean by the salts.
Yeah, by
Is
ocean,
that
like the Bay Bridge,
ocean?
the new Bay Bridge.
Type 5. Because there you have all sorts of salts, sulfates. This is what you want. Again, if you're pouring that Bay Bridge in a winter, you may want a fast curing. If you're doing it, Bay Bridge is probably cold areas, right? It's probably, you're talking about type 5. And if you're pouring, let's say, in water and it's very expensive, type 3. So you have to really, there's not a simple answer to that. You got to really evaluate your crews, the cost of material, what is available. But you probably type 1 and 2 is probably not for your Bay Bridge project example. You probably want a high strength, so I'm leaning towards type 3. If you talk about ocean water and stuff, probably type 5. So you're the type 5 or 3 if it was up to me to specify. Shamil, did I answer your question?
Yeah, because Long Beach did the same thing, right? Long Beach has it also. So, no, it's not on water, but yeah, I think it's over water too.
Yeah, Long Beach, we don't have high sulfate. The soil, it's not like Irvine. Long Beach, if you're doing something in Long Beach, would be type 3. If you're doing the same bridge in Irvine, would be type 5. Now, there are other elements that you add to the concrete to make the concrete hydraulic, to make sure the concrete strong, and also you can pump it high, you can, it's more fluidy without adding water to it, more liquid. We mentioned this last week a little bit, but all of these are very, as you can see, very fine material. They're almost as fine as coffee. You know, when you get a Nescafe or you get a grinded coffee that you can make coffee quickly, fast making coffee. These are that level, that refined. Like slag or slag cement, these are something that's a byproduct of the steel making. Pozzolans, again, chemicals, they are modified cements, and they all come in to make the concrete more airy in training, for instance. If you want concrete to be light and you want the concrete to be able to expand and contract, these are the kind of chemicals you use. Now, the cement that we talked about, the Portland cement, it could be used in masonry cement, mortar cement. Now look how many kind of cement there is. White Portland cement, plastic stucco cement, waterproof Portland cement, expensive cement. Now, if you go talk to the stucco person, he uses cement for his stucco, but he uses plastic stucco cement. If you use a mason who uses it for a grout and he uses cement between his masonry bricks or blocks, he uses this cement. For mortar, is this cement. Obviously, the white Portland cement is for a white project, the project that you want your concrete to be white. Very expensive, very hard to get. Not everybody produces this. Waterproof cement, Portland cement. Again, this is a Portland cement that if it's expensive, these are, of course, but if you're close to the water does not impact the components or the aggregates of that concrete. And then expansive cement is a cement that can expand and contract. Then you get to the cement that there is no Portland cement. You use completely different kind of glues. Aluminums, magnesites, rapid setting. These are other glues. Doesn't have to be all natural Portland cement. Mankind has come up with other kind of glues that can hold these materials together. Well, when you mix these materials together and you test them, you will see in one day different kind of cement, they achieve different kind of a strength. All of them, at the end of the 28 days, they have achieved most of the strengths. But even at 3 months, they're ultimately all 100% of what they're supposed to be. Type 5 sulfate resistant, because of the chemical it has, it takes a little bit longer time to reach its ultimate strength. This ultimate strength compressor should not be mixed with the look or appearance. All of these concretes, after 28 days, code allows them to reach or to be serviceable, to be used. But as you can see, some will take a little bit longer to ultimately reach the remaining 15% of the strength they're supposed to be, or 25%. Transporting cement to the factory is done also with the truck sometimes. But this is shipment of cement to customer. This is not concrete. So if you see a cement truck, don't mix it with the concrete trucks. This is just carrying product. Shipment of cement to customer is made either by bulk or in 94-pound bags, or they got even, I think, a smaller bags too nowadays. They got 70-pound bags. When you go to Home Depot, they got these 94-pound bags, and then this 1 cubic feet, which is pretty heavy. And then they got another size, which I think is 65 pounds. So if you need big amount of this Portland cement, the truck needs to bring it. That's what the concrete batch plants they use. They go buy the concrete or Portland cement from the cement manufacturer. But if you want to buy smaller quantities, you have small jobs, you can go to Home Depot, pick up 2 bags. 2 bags of the concrete, which is 1 cubic. You mix 2 buckets, 4 buckets of water, 1 gallon bucket, with rocks and stuff, gives you a pretty good glue, pretty good concrete. So in transporting concrete, there's a large industry involved. Trucks, truck repairs, truck maintenance, truck drivers. So it's not it's a major industry. Trucks, rails, barges. Some islands of the world, you see resort built in island, but the island has no concrete. The island has no line. So everything has to be shipped to those islands. It happens all the time. So they make barges of cement that has to transfer across ocean to get to the destination. Now, what don't you want exposed to the harder cement is the water, moisture from ocean, because then it becomes hard, and there's no point. If you're delivering that powder to be mixed in the island, on transport, it can become hard. So you got to have a lot of special equipment on the barge to get the concrete to the island or wherever it is. Country of Japan nowadays has got special boats and ships that pick up material from different parts. Remember, Japan is not very big either. But they have contracts. They go pick up lime from one part, someplace in the world, clay in another part of the world, ferrous oxide in another part of the world. They mix it in the ship and deliver it to an island, deliver it to US or wherever they have to deliver it to. Again, huge cement trucks. This is not a concrete truck. Everything pneumatically gets pumped into these trucks, and they go back and forth delivering the cement. Now, we talked about the quarries and mines. Here's are samples of some parts of the world that they have pozzolans. They have the kind of chemicals that everybody else needed. So some people, all of a sudden, they inherit a piece of land from their grandpa, grandma. They either know it or they don't know it. They start excavating, and then all of a sudden, before they know it, they're millionaires. Because they're sitting on a mine. Later on, I'll show you, this is fly ash. Fly ash is a result of volcanic action. Some parts of the world, if you expose the ground, you may have fly ash. This much of fly ash. Somewhere along the years, some kind of volcanic action happened. All this fly ash came and got trapped in this valley, and now somebody owns it. If this man is 6 foot tall, this is about probably 15 feet tall mine. Yeah, there's a low price to pay for this material. Now, pozzolans are also kind of a glue. They have been through the heat process naturally because of the volcano. They contain the right chemicals, but because they came from the Mother Earth out, they're very strong. They got all the stuff that man tried to make is God made available in a mine or in a quarry. silica fumes. This gray material is a result of reduction of the highly coarse purity quartz with the coal in an electric arc furnace in the manufacturing of silicon. Silicon Valley. We learned that we can use silicons for our chips. But in order to make the silicon, you're going to very much like in order to make metal, you have a lot of byproducts that people have to find and use them somehow. Anything you produce has some negative garbage or negative residue or leftovers. This is the silica fume. As a result of producing the silica chips or converting the quartz to silica. Why do we use silica or silica? Can anybody tell me why they use in computers or chips? Why we realize it's good to make computers with?
It's a conductor.
It's just
What is that?
Is that a conductor?
it's like a semi.
It's not exactly. It does not conduct electricity.
It's a semiconductor.
It's one of those elements that it does not conduct any electricity, no matter how small the chips are. Though the electricity will destroy the chips. For your computer to produce, have this shiny light on the screen, or be able to process 3D renderings, it needs to do a lot of electron movements, but you can't tolerate any heat. That's why humans go with silicon. Countries of the world that they can produce silicon made a lot of money, but to produce silicon, you have this byproduct. So they take this byproduct, very much how you make steel. You have byproduct, they put in a concrete, they get rid of it. People don't notice it. That's one way to get rid of. At the same time, it's a good way to make money out of the leftovers. So this was what I was trying to talk about, the glue. 5 kinds, different kind of glues, some man-made glues, some naturally existing glues. You put your hands on it, you got your glue. Now let's talk about aggregates. Aggregates are almost the same thing too. Some parts of the world, there is no aggregate. It's all clay. If you go to Costa Mesa, if you go to some cities, there's no rock, there's no aggregate. But if you go to Redlands, you still have rocks. If you go to St. Gabriel area, Pomona, a lot of rocks. Riverdale. So again, rocks is also is a curry, it's a land. You can sell your rock. If you have a piece of land has got the right rock in it, you can stockpile it, you can sell it, but you got to know a little bit about rocks, how to make money out of your rocks, if you got the land. So here's the rocks. When you get a 1 cubic yard of the concrete or rocks, or you scoop a rock, and mix it with some water. If the rocks go on the bottom, 15% of cement on top, and 26% of water, that could be 1 cubic yard of your concrete. It has aggregates, it has cement, and it has water. If you use 3/8" rock, that's the result you get. If you use a bigger rock, 3/4, this is what you need to get to reach that right combination. If your rocks are bigger, so you will have lesser room for the water and cement. So here as the rocks grow. So if you're doing a big mine or big dam or big concrete structure, you can have 6-inch rock, even up to 6-inch rock in it. But you got to have right equipment, right tools and all that. But if you're doing a building or a home or a high rise, 3/8 of an inch is the rock you want to use, or 3/4 inch. So this example shows you different kind of usage and different kind of rock for different purposes. You don't want an 8-inch rock or 6-inch rock in your 6-inch residential slab, because that rock will be exposed. But if you're doing 24-inch dam or 4 feet dam, you can have 6-inch rocks in a dam. So the more massive structures you have the right equipment, of course, but you're able to put big rocks in that. The more refined structure, residential structures, buildings, parking structures, these are kind of rocks you want to have. And these are the mixes that you're looking for. So this slide, for first time, introduced the size of rock. So let's say you have a land with the rock. First order of business is you need to sieve your rock and pile it up differently. That's how the gravel companies work. If you go to, I'm trying to use the name of this city's Inland Empire, that you see they have land with the rock crushing in it, and they pile up rock. Rock is used in landscape design. Rock is used in concrete. Rock is used for the water desiltation basin. Rocks come different colors. Sometimes if you have a white rock, Home Depot, for instance, sell white rocks. Have you seen white rocks? I'm sure you have. They're very decorative. They're pretty expensive. They use it for landscaping, just a very little areas in homes and all that. But rocks could be black, pitch black, or rocks could be gray. So rocks, based on their color, based on their texture, based on fine values, have, even there are rocks that you can buy them at jewelry stores. You have seen very light, nice blue rocks or pink colored rocks that people get from the different mines, and they make jewelry out of it. So when we talk rock, don't underestimate rock and aggregates. Because of their strength, because of their composition, their color and stuff, you're different kind of usage for them. And they put them in concrete, exposed concrete, they mock them, they put them in trash. So architect engineers use rocks in their buildings completely differently for different purposes. Now, rocks and sands. Fine sand, you come from desert. You don't get your sand by the beach, because sand by the beach is no good. Sand by the beach has a lot of salt in it, and salt is detrimental for concrete. So you don't find their concrete batch plants go scoop up sand from the beach and take it to their plant. No, that's not the kind of sand we're talking about. We're talking about the sand that doesn't have a salt, it's not by the ocean. Same thing with rock. There are rock shapes also important. The rock that we want for concrete is a jagged rock like this. We don't want a very shiny, sleek rock, because this is what's good for concrete and keeps it together. A lot of times, I'm sure you see it along the freeways. When Caltrans works on roadways, they demolish a bridge or demolish a part of the freeway. They take all that concrete, they crush it, because that crushed concrete works as good as rock. And they put that back to work. So in California, in most of the US, there's a regulation that whenever you crush concrete, you got to recycle it. So it doesn't matter where you get the concrete. A tilt-up building demolition, high-rise floor, old parking structure, or old warehouse, wherever you demolish a concrete, that concrete has to be recycled. If it's large recycling or large building, they bring the recycling plant to the job site and they crush it right there and then. If it's only like a few big pieces, they put it on a truck, they take it someplace else to crush it. But most of the significant jobs, big jobs, you don't want to haul away big chunks of concrete. It becomes very expensive. So you crush it right in the spot, you bring a crusher, you crush it right at the job site, and you move it. I had a project in Long Beach 5 or 6 years ago. They had to demolish I want to say 6 or 7-story courthouse. So they took the chunks of the concrete from the building, they lowered it, they crushed it, they shipped it. You may own a land like this, and before you know it, you start digging, you find rocks, riverside. And those rocks have a fine value. Most of the rocks that we find many years ago used to be a bottom of some kind of a river. The reason we have so much rock in San Gabriel area near us and not much rock by the ocean is very clear. By the ocean, you get the sand, and by the mountains, you get the rock. As throughout years, the rain, snow, flood brings the rock or decompose the mountains, you find rocks. And these rocks sediment or they are by the foothills. And as the rock further tumbles down the river or become more refined, it comes down close to the ocean and because of rivers. This goes back to the geology of the world and where some areas, rocks are heavy, they go down and a powdery dirt comes up. So on top you see golf courses, I see landscaping, parks and all that. And this might be what you see on the surface, but you dig down, this is what you see, big rocky area. If you have ever been a contractor, work on Riverside area, you would know this. Who has ever had a job in Riverside area? To work as a contractor or as a grading contractor, any dirt work, anybody has been exposure to? No? I was once a contractor. When I was 40 years old, I decided no more, I want to open up my own company. So I opened a construction company for 2 or 3 years. And I got lucky and I had several big jobs. A couple of them were in Riverside and Claremont colleges. Did 3 years of that. But one thing I learned, that if you do not know enough about the train or places you work, don't just stipulate things. Go visit the job site. One of the things that the video that I showed you last week said, the guy said, go visit the site. If you ever want to build something, no matter how big or small, go visit the site. Because if you build in Irvine, you have some kind of a problem, you have to know about type 5 concrete. If you're building in some parts of Costa Mesa, you need to know about the clay. And if you build in Riverside, you need to know about the rock and deal with rock. How do you excavate in rocky area? Can you tell me? What do you need to build a good sized building where underneath is rock? What's the problem?
Need a core
Go
in
for it.
there.
What is that?
Need a coring machine, like
I'm
a
not
core.
talking about
like
bedrock.
rock
I'm not talking about bedrock. I'm not talking about bedrock. Because bedrock happens 20 feet deep, 40 feet deep. I'm talking about first 20 feet. Generally, you don't find bedrock in first 20 feet. Let's say you want to build a 2-story home. in Riverside. What's the problem? What's the difference between two-story home foundation and two-story home in Irvine?
It's gonna make
You need a.
make the building the foundation, you know, or
You're gonna have to have a bigger like stem wall or deeper footings.
No, let's say the building, the load is the same. Let's say identical building. Let's say the load is not different. The issue is the sowing. Try to dig in the rock. The trenches collapse. When you put a backhoe and dig the trench, if it's rocky, all the rocks pour back in. You follow what I'm saying? If it's the dirt, when the backhoe goes down and dig, you get the cut, you get the trench, but not in a rocky area. In a rocky area, as you take the rock off, the rest of rocks pour in. The other thing, when you use a backhoe, which is an expensive machine, the backhoe has got teeth. In front of the bucket, they got the diamond teeth. The diamond teeth cuts into the dirt. Have you seen the front of the backhoe? The load, it's got the teeth, small teeth. When those teeth hit the rock, what happens to the teeth?
breaks or it bends.
Yeah. So no backhoe driver wants to operate in that area because the machine go bad. If the backhoe digs into the dirt, it goes in, the teeth are good for 20, 30 jobs, 40 jobs before you have to change it. So the backhoe driver can do 50 jobs before he has to do something with a bucket, but not in a rocky area. They go bad. So there's a multitude of issues that you have to be in the field and you should have experienced it to know what I'm talking.
Do you mind if I ask you what was the downside of being a contractor, since you said you just ran the business for only like 2-3 years?
Contractor, don't become a contractor unless you work for somebody for 10 years or 5 years. What I did, I went through education. I had 9 years of education. I worked 9 years for City of Irvine, built projects and parks for the Irvine. And then I felt like I know everything about construction. Yes, I did know a lot about construction in Irvine, but not enough about construction in LA or Riverside and all that. So I ventured outside, and then I got my hands slapped, if you know what I mean.
Oh yeah.
But you got to get your hands slapped because then that you learn from it. I won't make the same mistake next time when I go to Riverside or when I project design for people. So it's catch-22. You got to get burned a little bit. You got to dabble into it. You can't just sit outside and read books. But just be cautious and work with good people and work for somebody knowledgeable first to learn experience. So now we'll talk about aggregates. The different aggregates. Not all the rocks are the same. Very much like cement were different, aggregates are different. Some aggregates are very sound, very strong. Some aggregates do not react with chemicals. They are more inert. Some very abrasive. They produce chemicals or they have chemicals that could be detrimental to your concrete. Some has got good shape. Some have good surface texture. Some are heavy rocks, specific gravity. Some are lightweight concrete. We talked about this last week, how you get the lightweight concrete. Okay. So much material are light. Some rocks absorb water, which are not good for concrete. And some material are not dense, so they have some moisture. So even what we consider rocks, they have been tested. Why the American is still testing materials? And almost every material has this designation. So if you are in Boston, let's say, and you are the owner of the land with some rocks, and you are, let's say you're in Riverside, and you are owner of the land and have rocks. What you can do, figure out these ASTMs and follow this, and then you can sell your rock based on ASTM C88. But somebody got to come test your rock, make sure your piles are proper piles of rocks, they're not mixed match and all that. And if you can meet any of these standards, your rock worth money. And it's used for different purposes, making concrete or other things. So industry of rock in US is very regulated. And that's why we can build high-rise building. That's why we can build structures that don't collapse, because they'll be tested. Unlike other parts of the world that they make dams and bridges and very soon they go bad. This standardization is a big part of the success in US. Again, for the cleanness of the material, there are different ways. There are more aggregates, more smaller materials. There are different kind of testing done. Somebody said they are going to be talking about the, I guess that was you, Sam. You said new concrete technology and concrete mix. You may get involved with some of this. You may want to bring in some of the STM standards on what you're going to be talking about.
Sure thing.
One thing that, again, if I get a chance, I'm pushing to take you guys to a concrete lab is places like this. These materials, when we say they're tested, when Caltrans buy rock or Batch Plan buy rocks, they test them. There are companies who come and test, certify these are the rocks. And there are tumblers, there are machines that the labs have that they can take the samples of your stockpile. They take random samples of the stockpile and they take them. And if all those samples or majority of those samples meet that ASTM standard, they come and certify that stockpile as an approved material. And then Caltrans buy it or somebody buys. Here are the sieves that they run the samples through, the lab technicians, and they can say, yeah, this material meet that, is granular enough to meet that ASTM standard, or no, it's not going to meet the ASTM standard. So these are the electrical sieves that they, as you put the aggregate on top, the aggregate goes through, and they can tell you 10% of the sample meet the ASTM, 20% meet the different ASTM, and this way, after these aggregates pass different sieves, now the manufacturer can say, I have 10 tons of this aggregate, 2 tons of that aggregate, and they price it and sell it. So the amount of, one of the things about the aggregate is the size. And the way they determine size is based on how much of it passes different sieves. They have different sieves, different sieve numbers. And after this pass these sieves, they can size the aggregate. These are the size of the sieves or screens. Industry calls them number 8 sieve, number 16 sieve. And based on your material that passes through, you identify the material. There are different tables for grading of rock, as you can see. Particle shapes are also, as I said, is important. These slick rocks are not good for concrete, so they call them category A. Category B is better. Category A consists of good, well-rounded river rock or river gravel containing very few elongated or broken particles. Class B is the other way around. A granular concrete makes the concrete slightly stronger in flexure and than round, but makes it harsh concrete to work, sometimes requiring more sand and cement and water for workability. Yeah, because they have got rough edges. You have to mix more sand to make it work. Rocks materials have water too. So you want the material to be as dry as possible to reach the ultimate strength that you want. This shows basically the sand or gravel quarries or mines, machinery that operates in getting the rocks from the hillsides. Have you ever been exposed? Have you ever been at one of these places by any chance? Because we don't see too many of them in California. We see a stockpile, but these are generally not for people to go see or
Maybe
but
not
very
exactly
heavy
just
machine runs
maybe
them
not
up.
exactly just sand or
Comic, please.
sand or but my dad used to work at a gravel plant mainly for like landscape rock. I mean, they sold other compaction type grades of rock too, but it was in Arizona. And I remember, yeah, they would blast out of the hillside and stuff. They would do blasting so they could get, big rocks. And then they had rock crushers and all that.
Yes. Now, a place like places your dad worked, they got a lot of these inclinators. The rocks go up there. They wash them. You see how they wash them to clean them, to get rid of any residue that's connected with them. As they wash them, as they tumble against each other, and as they go up the escalator or inclinator, they get rid of the bad material and the solid rock and gravels expose themselves. As they move up, their tumblers, they gradually separate them from each other. The bigger stuff stocks in the bottom, and then they send them back to crushing. This plant, they have also tools. And again, after all that process is done, you have stockpile of the different rock, aggregate, and sand. Here, they take a sample of aggregate, they compress them to make sure that the strength of aggregates are determined or we know what they are. More samples of the sieves and sampling rocks and separating rocks from each other. This is how we find the 3/8 of an inch rock, 3/4 inch rock, all the way to 6-inch rock. We talked a little bit about lightweight and heavyweight aggregates. Aggregates for structural concrete weighs as little as 90 pounds per cubic feet. I haven't seen 90 pounds, but 110 I have seen. Apparently, you can get them as light as 90. Special low-density insulating concrete with a density as low as 15 pounds per cubic feet are made with certain expanded minerals and foams. Apparently, industry can do very wild stuff with foams. Heavy concrete for radiation shielding and counterweighting may have a density of 300 to 400 pounds. So concrete could generate 150 pounds, 110 pounds, can go as light as 90 pounds cubic feet to as heavy as 300 pounds a cubic feet, depending on what you're doing. Now we're done with rock. You know the courage, you know there's different size, you know how to clean them up, or you know the Texture is important, shape is important, and also the integrity, how strong the rock is. So 5 or 6 things you should know on top of your head. Size, shape, texture, composition, and I guess the strength. And where you can get them, where you can buy them, you have some fair idea. So we're done with the glue. We are done with the aggregate, which is the second important thing. The third one is the water. So you got the glue, you got the aggregates. Now let's add water and mix it together. What kind of water? Water has to be potable water. Water cannot be river water, cannot be ocean water. You know why? It has to be purified. It cannot have alkalis, it cannot have calciums in it, it cannot have salts in it. So drinking water. That by itself has a price. That adds to the cost of the plant that makes Portland cement. If you use a bad water or bad aggregate with the chemicals, that's what's going to happen to your rebar. So you want to make sure the water is pretty inert because there's a lot of water in it and it's making your glue. And until the water dissipates, it's going to be containing all around your rebar. You don't want your water to be detriment and rust your rebar. Seawater is one of the worst things. Seawater will get into the concrete and eventually all the piers, all the bridge supports in the water, fairways, all that go bad. So you want a very dense cement. You may want to use the special rebar that doesn't rust to make sure, and you don't want any unpure water initially inside your concrete. So that was all about water. Clean water with no chemicals in it. That's what makes your glue. Now, what is admixture? We also talk about other things you can add to the concrete to give it a color, to give it a more fluidity. You need to have a knowledge of that, and all that is under ASTM-C 494. Somebody wants to learn more of this, if you Google it nowadays or chat GTP on what is ASTM-C 494, within a half a day, you can be very knowledgeable about these chemicals that you need to add to your concrete to produce a better concrete. So is it worthwhile to learn? Absolutely. Contractors make a lot of money just by saving headache, by spending a little bit money right at the beginning to get a better product at the end. We know you don't want too much water, but if you need liquidity, you need to use admixture. When do you need liquidity? When you're pumping concrete on a high rise or in the middle of ocean, when you have a pumper helping you pump. You cannot have a big rocks because that's not pumpable. At the same time, you want a liquidity which water would not afford it for you. Retarding admixture you already know. Accelerating admixture you already have. We have talked about. Then you get a combination of these. You get a water retarding reducer admixture or water reducing high admixture. And then plasterizers. I will show you videos that some of these materials are used so you guys become more comfortable with it. These are some statistics behind what you can do to get high strength with with less water. So as you add plasticizer into your concrete, it delays the curing a little bit longer, but even you reach higher strengths. With what concrete can, with the plain concrete can achieve, let's say 4,200 PSI, same concrete with plasticizer can get to the 55,000 PSI, a lot stronger building. This is the same study done under different temperatures. What you can do if you have to work in 100 degrees Fahrenheit. General concrete is poured within the 50-degree range. But if you have to work in Vegas area or some warm area, the name of the game is the compounds or admixtures that you add rather than water to make the concrete workable in Vegas. A lot of measurements are done. There's a lot of tables. When you order the concrete in Vegas, you tell them that you're going to be pouring in 100-degree temperature, then they give you right concrete, more expensive. Air entraining cement is also an interesting one. This is where you start in a simple language. You add foam or you add detergent into your mix. When you add detergent into water, it creates bubbles. When you shake that water, it becomes full of bubbles, like your bathtub. If you put enough of it into the concrete, it creates, when the concrete cubes, when all the water is lost, it leaves those microscopic holes or air entrapment into the concrete. As the concrete cures and reaches the ultimate strength, you get a product that's lighter. You get a product that's got microscopic holes in it, so when it has to expand and contract, that's better. Doesn't crush against each other. It's got a room to move. Less cracks. The air bubbles are created during mixing of the plastic, concrete, and most of them survive to be a part of the hardened concrete. They call it plastic concrete because it has ability to move like a plastic. It's more plastic. When you have air entrained, that means all your holes are full of air. So when it's full of air, other materials cannot get through it that easy. So when you mix air into your concrete, your slump increases. Is it good for a slump increase? You want 4-inch slump. You don't want to increase it too much. Water cement ratio increases because you have less rocky material. You have lesser heavy material because air has taken some of the space. Because you have microscopic hole, the sand percentage goes there, fines. Cement content decreases, and so on and so forth. Now you can add agents to your concrete to get different colors. Is it used all the time? If you want a gray concrete or black concrete, you need to add oxide iron, carbon, black. If you want a brown, you need to put red iron oxide or some yellowish or brownish oxides. If you want blue, you will use cobalt. Cobalt is a rock or stone that's blue. You grind it and you put cobalt across. It's a kind of metal. If you want green, you use chromium oxide. These agents add color to the concrete. And you have to use white cement for white concrete. Now, here's an example. I'll show you videos later on, but this picture shows you a high-rise building, whole bunch of rebar, a floor to pour. You need to have very liquid concrete with pozzolans or a concrete that's very strong at the same time, very liquidy, so you can be pumped 10-story tall. It has to come out of a hose like this, so it can be, the gravels cannot be too big. Plasticizers is also a name for super plasticizers. These are materials that make the concrete high slump, but strength is not reduced. High slump is when you really want to shoot the concrete high and high rise. All right. We talked enough about few things that you got to have a little knowledge to understand concrete. Any question at this time about the lecture part of this class? I'm going to pause recording first of all. We'll stop it.